So today we're going to look at composite functions. A composite function is essentially a function that's stuck inside another function. So we've got two functions here. We've got function f, and f is a straight line 2x plus 1, and it has a restricted domain between -1 inclusive and 3 not inclusive. We have a second function called g. G is a positive parabola that's been moved up 3, and it has no restricted domain. So we've been asked to find the following. We're going to find f of g of 1, g of f of 0, an equation for g of f of x, and the range and domain of g of f of x. So we need to learn what this notation means. This is the notation for composite functions. You might also see it written like this sometimes, with a little circle. Oops. It can sometimes be written like this. So these mean the same thing, f of g of 1 or f of g of 1. Okay, let's talk about what this means. So what this essentially means is we're substituting 1 into the function g, taking that answer and substituting it into f. So let's have a look at what happens. So for step 1, let's just find what g of 1 is. So I'm working out this middle part. So we look at g and we substitute 1 in for x. So 1 squared plus 3 equals 4. Okay, the next part, I have this answer which equals 4, and so now I need to substitute this into f. So f of 4, we look at f and we find x and we sub in 4 for x, and this equals 2 times 4 plus 1 is 9. So the overall answer for f of g of 1 is 9. Okay, let's do something similar for the second one. This time the letters have been swapped around. So in the first question, we substituted 1 into the equation for g first, and then into f. Here we're going to substitute into f first. Okay, so we're subbing in x equals 0 into f. This is f up here, so 2 lots of 0 plus 1 is 1. So I've worked out what f of 0 is, which is 1. Now I need to do g of 1. So now we substitute x into g. So 1 squared plus 3 equals 4. So the overall answer to g of f of 0 is 4. Okay. So here I've done things in sort of quite a bit of working out. We could have written it like this if we'd wanted to. F of g of 1 we could say is equal to f of, and I'm going to do the calculations in here. So I'm going to sub 1 into g, which we worked out was 4, and then calculate this part. So you could do each calculation separately on a new line, or you can do them all within itself. Okay, so that's how composite functions work for substituting in a single number. We have a function that's stuck inside a function, or a function that's being substituted into another function, sort of an inner and an outer function. So we'd like to find the equation for this. And we're just going to find the equation for g of f. We're not going to do f of g. And we're going to use the same idea when we substitute it in a number, except now we'll substitute in just x. So g of f of x. Okay, so just like before, we substituted in to f first, got our answer, substituted into g, and got our final answer. So I'm going to work out what f is. F is 2x plus 1, so I'm subbing in my equation for f of x. And now I need to substitute this part in wherever I see an x for g. Okay, so that's going to be, instead of writing x squared, I'm going to write 2x plus 1 squared plus 3. Now you can expand that if you like. I'm just going to leave it like this. So our composite function has an inside function of 2x plus 1 and an outside function of x squared plus 3. And this is a parabola that has been moved left a half and up 3. All right, let's just have a quick look at what that parabola might look like, because the next question asks us to find the range and domain. So it's in turning point form. It's a parabola that's been moved left a half, up 3. It's a positive parabola. Okay, so the domain for this parabola is all real numbers, and the range for this parabola is 3 inclusive up to infinity. Now, you might be tempted to think that they are our ranges and domains for the composite function, but it's actually not correct. And some funny things happen when you have restricted domains here in your original equations. This is certainly the range and domain for the equation 2x plus 1 squared plus 3, but it is not the range and domain for this function g of f. So to try and work out the range and domains, I'm going to draw a function machine. And it's going to be a conveyor belt. It's going to have two machines, one for f, one for g. And we need to think about the order to place our machine. So to work that out, we need to go back and look at our working out for g of f of x down here and think, what did we substitute into first? Well, we subbed into f, got an answer, then subbed into g and got an answer. So when we make our machine, the f machine is going to be first on our conveyor belt. So I'll make a machine here for f, and we'll write our equation inside. So this is function machine f. We'll make a second one for g, x squared plus 3. And our conveyor belt moving along. So we have stuff going in, stuff going out, which then feeds into g and comes out the other end. So in our previous example, let's see what happens when we feed in x equals 0 in our conveyor belt. So we have x equals 0 going in to f. We sub that in, we get 2 lots of 0 plus 1 is 1. So we have 1 coming out. Then 1 is fed into g for the value of x. And we get 1 squared plus 3 is 4. So when we put 0 in at the start, 4 is what we got out at the end. Now to work out the range and domain, we need to work out what happens for all possible x values and the corresponding possible y values. So I'll just get rid of these. And what we'll do is we'll send in all possible x values. Okay, so f is first. And before we start, we should probably draw some graphs so we can get a better picture of the range and domains of these, because that will be important. So this is a straight line that's been moved up 1 and has a gradient of 2. But we have a restricted domain. So we don't want the whole line, we just need a line segment starting at x equals -1, and we have a square bracket, so we need a closed circle. The corresponding y value, if we substitute in -1, will be 2 times -1 plus 1, -1. And 3 is our other limit, x equals 3. We have an open circle because we have a round bracket. Corresponding y value, will sub 3 in. 2 times 3 is 6 plus 1 is 7. And the line segment that we want is this part here. So the domain of this graph is -1 to 3, and the range is -1 to 7. Let's quickly do G. It's a parabola, x squared plus 3, so a parabola that has been moved up 3. No restricted domain, so our domain is all real numbers, and our range is 3 to infinity. Okay, so we've got that information. So now let's work out all possible x values that can be fed into f. Well, that's just our domain down here, -1 to 3. And let's work out what can possibly come out of f, or what are the corresponding values, or another word, what is the range of f. So we've worked out the range. All possible corresponding values will be -1 to 7. And this is now what's being fed into G. So the reason that our domain and range here wasn't necessarily correct originally from the equation is because we have a reduced domain going in. So we are not sending in all real numbers anymore into G. We're only sending in -1 to 7. So we need to go back and look at this graph and work out what section we're using when we send in -1 to 7. So if x equals -1, the corresponding y value will substitute in -1. -1 squared is +1 plus 3 is 4. -1, 4. Let's send in 7. So when x equals 7, we have 7 squared plus 3, 52. So the section of the graph is only this part here. So we now have a restriction. So when we send in -1 to 7, the corresponding range coming out is 3 to 52. 3 inclusive up to 52. Now I've got an error here. This should actually be an open circle because we have a round bracket. Okay, so to answer the original question, find the range and domain, we can read this off our function machine. This part here, this is the domain. This is the domain of g of f of x. And the range is what comes out at the very end.